The main sponsors are Southeast Conference, Golden Valley Electric Association, and Alaska Housing Finance Corporation. And that's also with the support, of course, of the Cold Climate Housing Research Center, Information Insights, and Solarize Fairbanks. All right, next slide. So before we get started on all of the tips and tricks that Emmett is going to go into, want to take a moment to look at some of the new federal tax credits that are available actually starting this year on a number of issues. One is on solar electricity. It's at 30% of cost. There's also some around wind turbines and battery storage, but there's new ones that are available really around heating, cooling, and water heating. And so as you can see here, there are tax credits available on heat pumps, biomass stoves, efficient air conditioners, efficient heating equipment, efficient water heating equipment. And there is a link here. This is all off of the U.S. Department of Energy website. Also, there's other energy efficiency upgrades that you can go ahead and take a tax credit for. Some interesting ones include actually even for energy audits. And so just want to make sure that everyone is aware of these tax credits and have a chance to take the time to go ahead and look through this as you are considering different upgrades to your home. And then next year when you're looking at sort of the tax season. All right, next slide.
Sorry. There we go.
Awesome. And so just want to take a quick moment to talk about some of the Solarize campaigns in Alaska. This is not the solar presentation, but we do have support from the various Solarize campaigns in Alaska. And so for folks who are in the Fairbanks North Star Borough and also those in the Mat-Su Borough, there are 2 active Solarize campaigns for 2023. The Fairbanks campaign is working with 2 solar installers, Renewable Energy Systems and Arctic Solar Ventures. The Mat-Su campaign is working with 3, Alaska Solar, Arctic Solar Ventures, and Renewable Energy Systems. Some really fantastic changes to the Solarize campaigns. Both campaigns have worked with installers to basically give back. So they donate a percentage of the total kilowatts installed through that Solarize campaign towards free and low cost energy or solar PV systems for households or organizations. And those are households or organizations that are in the community and also selected by the community. And that's on a place by place basis. So that would be different for the Fairbanks area and the Mat-Su area. Next slide, please. And also, of course, just kind of a reiteration of some of those tax credits. But these Solarize campaigns have asked each installer to go ahead and offer competitive retail rates. And then on top of that, you have that 30% tax credit for homes and businesses. A change this year out of the Inflation Reduction Act is that organizations that were previously not eligible for that 30% tax credit because they didn't pay taxes are now eligible for a direct pay option. And that's tax exempt organizations like nonprofits, charities, university, also government entities, and rural electric cooperatives. And I will say this is new as of 2023. And so before making any decisions on this, everyone encourages organizations to take a hard look at this with their tax professional, but this is something that is newly offered in 2023. Another fantastic resource is the U.S. Department of Agriculture REAP grant, and this has been offered in Alaska for many years. The change in 2023 is that this now provides a grant for up to 50% of a solar PV installation. It also covers 50% of energy efficiency upgrades that are non-emitting. So that do not, basically, it wouldn't cover sort of the upgrade of a fuel furnace, for example. But there are a number of upgrades that would be eligible for that 50% grant, and it's specific to rural small businesses. And so, at least in the perspective of the U.S. Department of Agriculture, those are businesses that are outside of the municipality of Anchorage. And I think with that, I'm going to close the poll. And oh, thank you. I forgot there's one more slide. So I do want to make sure that if anyone is at all interested in this US Department of Agriculture grant, there is a fantastic woman who is based out of Palmer, and it is her job, her name is Misty Hull, to talk to you about that specific grant. And so here's her contact information. If you're interested to hear more about those solarized campaigns, there's some email addresses and a QR code for the Fairbanks and the Matsu solarized campaigns. And so with that, I'm going to stop and hand it over to Emmett, and I'm going to go ahead and close that poll.
Thank you, Jamie. Thanks for all those updates. Good information. If you're here for energy efficiency, you're in the right spot. Again, thanks to our sponsors that helped make this class free for everybody. I'm kind of, I consider myself a building analyst. We do a lot of diagnostics and testing, but I'm a certified energy rater, air barrier auditor, thermographer. I have a mechanical administrative license and a plumbing license for the state of Alaska. And I also have gone through some training for healthy homes evaluator, and I've been a lead green rater for a period of time in the past. And so I have a vast experience looking at homes and buildings for energy efficiency. And so I kind of take a different approach sometimes. But one of the things I like to look at when I do an assessment on a home or building, and that's true of any building, I think, honestly, but comfort and health are critical aspects to an efficient home, right? If it's not comfortable, I don't think it's efficient. I don't feel that that's an efficient system or home, and it has to be durable, right? This homes has to last for the life of the home. Let's say 50, so 100 years isn't inconceivable for some of these older homes you've seen around. And there are three things that I try and focus on when looking at improvements, right? We can reduce energy use. Right, we can turn down hot water heaters. We can turn down thermostats with programmable thermostats. We can also make improvements, right? We can improve the insulation in the attic. We can improve the ventilation systems, its performance, and so forth. And then there's upgrades. And so reduce, improve, upgrade. Pretty straightforward. And I think that's we have to do that to all of our systems, right? We have to take that approach. Hopefully we don't have to replace and upgrade everything. We can make improvements on some things and make improvements on others and upgrade systems that are failing or whatnot. And so it's kind of a cycle, right? We trying to make a house more comfortable, healthier, perform better, and durable, sustainable. There are a couple different pie graphs from different organizations, but just to give everybody perspective on where some of their heat loss and energy is going in their house. And so about 42% nationally, probably closer to 50% in Alaska because we don't have any cooling. And water heating is a big aspect to energy use in homes. And so when we make an improvement to lighting, we could see a 50% reduction in lighting, but that's only a 2.5% reduction in energy use. I think lighting are great improvements, don't get me wrong, but we really have to, in order to start saving money, we have to start focusing on some of the bigger sections of the pie. And then air leakage is a big factor of space heating. And so our floors, walls, and ceiling are the largest areas typically. A wall floor joint has a huge surface area. And oftentimes a big leakage pathway for some homes. And duct leakage is another big portion of the pie. We could have, if you have a forced air system, you could have a duct system that's running through a crawl space or located in a garage and have a lot of leakage through that could be pressurizing and depressurizing your different zones. And so fans, vents, doors, windows, I think most people think about their doors and windows when they think about air leakage, but oftentimes, that's the air you feel coming in, but it's the air going out, right? In the picture of the house, 25% is going potentially out the top of the house, and you can't feel that. You oftentimes can't see it either, unless we dig into the attic spaces. And so it's easy to feel where the air is coming in, right? We can feel the cold air in Alaska. but it's the air going out that can be more important. You have to look a little harder for that. There's a great, I like to do resources on all of my pages here. And so if energy.gov has a home energy assessment, it's a great place to start. I think anytime you're working with a professional, whether it's an energy auditor or a mechanic, it's important to know what they're doing and to know their job so that you can have better questions and be better informed. And so if you're a do-it-yourselfer, that's a great place to start, the home energy assessment. They have some great tools there for you. And so definitely check that out. I like this slide because it's a Montana energy reference code. Not only do they put their entire energy code on as a public source for the state, you could, as an Alaskan, you could go and reference that and use it. But and Alaska Housing does similar things with their building energy efficiency standard. They can find lists on their webpage for the Bs. But this picture for me demonstrates what's really critical for a home, and that's the alignment of the thermal barrier and air barrier. And that air barrier system is oftentimes considered the vapor barrier, but it's really the combination of vapor barrier sheetrock. And the picture, if we look closely, you know, the crawl space is excluded from the thermal barrier, and that's common in Alaska at some locations, but sometimes we include it, we insulate the crawl space. And so when I came up with a few scenarios here, this is not always common, because with this design, you see, I've shifted now the red lines. The air barrier is not in alignment, and this is oftentimes what happens in homes, and it's hard to see. But it is somewhat easy to tell, right? When you're uncomfortable or you have freezing pipes in a bathroom area, it's oftentimes because, if you guys can see my mouse here, it's oftentimes because we have a misalignment between that red line and that yellow line, that air barrier and thermal barrier. Same with this bathroom area, that red line is at the lower ceiling, the yellow line, the insulation line, is at the top attic level. And so these misalignments are huge air leakage pathways typically. And they cause all sorts of problems, ice damming conditions and condensation, and freezing pipes. And so it's difficult to locate sometimes. But if you have these problems, there's something like this probably associated with it, or you just have a major air leakage pathway. And so this is helpful to visualize it and understand some of these aspects. And this is what I do a lot of thermal imaging, and it helps to visualize. For me, I think thermal imaging has helped speed up my whole learning curve to be able to see and understand how energy flows through a house and where air leakage pathways are. And so the top left corner is a basement wall that has a misalignment between that thermal barrier and air barrier. And so it ends up being a double wall above a block foundation that is only insulated on the exterior side, right? So it's only got that insulation on the exterior envelope, not the full cavity. And anytime we have a cavity that's half insulated, you're going to have cold convective air currents through it. And this is what it looks like thermally. You just have increased heat loss through there because of that convection. And so bottom left is just a double framed wall in a condo, similar signature, and same with this other basement wall, same situation. So this would be a common situation I find sometimes when you don't have that shelf for a below grade wall. It's oftentimes because they framed the wall up and it's not fully packed with insulation. The bottom right is a crawl space, and so sometimes the older crawl spaces, we used to bring air out from outside, ventilate it through the crawl space, and then that air used to come up through the house. And there was very little insulation in some of these older homes. And this was an older home. This ended up being 60s, 70s in acreage, no insulation, no air sealing in the crawl space. And the homeowner decided, well, I'm going to make a change here. I'm going to put heated floors. And so it just made for kind of a stark difference between the heated floors and the cold crawl space. But and so that's kind of what thermal bypasses, and anytime we get a misalignment starts to happen in a home, and they tend to be the root of the problems. And so when we look at a house, there are a lot of checklists available, and they go through to help us find these locations. The energy auditors look for this stuff intuitively, but as a homeowner, sometimes this is Greek, and so we look at areas that are important. We we often realize there's a comfort problem downstairs in a room because of on the lower elevation that has lots of air leakage associated with a window or floor, crawl space, a cold crawl space or something. And it's, and like I said, we feel that cold air coming in. It's a comfort problem in that room. Maybe it's a basement bedroom or something, but it's oftentimes the heat loss out the top of the building, out through the attic space, where we end up with durability and long-term sustainability issues. And so we have soffits and air leakage through attic hatches or light fixtures, ventilation, plumbing walls, the flue chases. These areas that we can't see and feel, we have to, that are really important for the long-term durability, because as soon as that air leaves the house, we start getting condensation problems. And so as we tighten up this home and make improvements, it's important that we bring in ventilation, right? We have to replace the natural ventilation that we're sealing up. We're trying to make our house tighter and more comfortable, more durable. We have to replace that natural ventilation with mechanical ventilation. And it's important to have a good working bathroom fan. And the bathroom fan can serve as a whole house fan. It can be designed with controls and newer features today with that are available today with bathroom fans. And then what happens next is we end up with a combustion safety concern that starts to develop. And so it's important to try and keep this all in context as we start to make improvements to our house. And so as we upgrade the ventilation in the bathroom fan, it's important not to oversize it. Same with the kitchen fan, not to oversize that kitchen ventilation, because our house is tighter, has less free air. And the combustion appliances, we may not have been able to upgrade those yet because they're expensive. So oftentimes, I'll go ahead and admit one extra person here. And oftentimes we run into these combustion safety problems with the older appliances that we have had in our homes, whether it's a natural aspirating water heater or a wood stove or an oil-fired boiler. And any of these appliances can backdraft. We can also get fumes being pulled into the house, right, from the garage. And so this seal between the garage and the house is important. And so we want to make sure we don't overlook this. What's important though is there's a lot more resources today than 10 years ago, 15 years ago. And so the checklists and the resources for where to seal, how to seal are available, and I'll show you a few of those locations. But it's important to keep some of these in context. And so combustion safety, we'll talk about that more later. Ventilation, we'll talk more about later too. So attic bypasses, let's get strange here. Attic bypasses are one of the biggest heat loss issues we want to be concerned about, because they often end up being real durability issues, right? We have too much moisture in the attics and ice damming conditions developing. The last couple of years, we've had really quite significant ice damming and snow buildup on the roofs, where so we've had a few roof collapse in Fairbanks a couple of years ago. This year, we've had a few in Anchorage. And so these conditions appear to be getting worse, and ice damming conditions appear to be worse this year too. And so to stop that, we have to seal up the attic bypasses. We have to get to the root of the problem, which is that warm air leaking up into the roof assembly, whether it's a cathedral hot roof or a vented attic. And so air leakage pathways can be hard to find. You can sometimes identify them just by inspecting the attic. There's a few things I'll show you what to look for. Thermal imaging has been, for me, eye-opening, because I can actually see where the air leakage is occurring, even though we can't visually identify it unless we opened up the wall, and that wouldn't be efficient if we didn't know there was a problem. But light fixtures, attic hatches are common air leakage pathways. This wall here on the right corner, the right picture at the top, is a wall that transitions from interior wall to exterior wall, right? So it's a second floor bedroom above the living room, and that wall fully extends 8 foot high, but it's cut off by the roof section right here along the cathedral ceiling and the roof. And so there's quite a bit of air leakage coming down the wall. When I depressurize the house and we look at it with thermal imaging, we can see where that cold air is coming in. And so this is a common problem I see even in new construction. So there is no home that escapes this problem apparently. if there is a wall that transitions from interior to exterior and it doesn't have blocking at that elevation, or that vapor barrier doesn't transition through blocking, transition through the wall to the other vapor barrier on the other side, right? So we have to come through and transition through the wall. That's a common air leakage pathway that ends up being all sorts of moisture problems and leaks that we get calls about, quite honestly, frequently. And then even floor joist. This bottom right picture is a floor joist that's connected to an attic space, and so there's no seal at the floor joist. It would be similar to this spot, if you guys can see my mouse, where the loft above the main floor has an open floor joist, and so air leakage is a big leakage pathway. Anytime we find it, we get to just cold air screaming through there. And so we have to seal that off like any other band joist or rim joist section by sealing it off with rigid foam or some sort of rigid blocking to separate that from interior to exterior. Same with the wall. We want to separate the interior wall from the exterior wall. And I'm not going to check on questions too often, but if you guys have questions and something, definitely raise your hand and I'll try and answer. Here we go. So what air leakage looks like in attic spaces, right? It's not always common sense, but it's easy to catch and see. Fiberglass gets dirty. It ends up being a great filter and a pretty good insulator. And so we have the top left picture is a flue. That flue chase there has not sealed at all. That normally would have a metal flashing and everything would be caulked in, fire caulking and so forth. And then there would be a ring to protect the flue and hold back the insulation so it wouldn't be in contact and there wouldn't be any fire hazard. That bottom left image is a plumbing chase, right? Oftentimes you'll see a plumbing chase located between a kitchen and bathroom. And many times this doesn't have any sort of top plate, or there's no continuous blocking at the top of that wall. It's fairly easy to fix. Some rigid foam would work great, or plywood, sheetrock, anything to seal that and block that air and then re-insulate. The top right picture is an interesting picture. That arrow is pointing to that wall. It's kind of a gable wall to the outside, and that should be a wood collar. And it's white. It's white because it's covered in ice. And sometimes I've seen a few walls like this just covered in 2 inches of ice. There's so much moisture condensing and freezing on that. And you see a little bit up in the roof at the where it's, and so you just get ice forming wherever the coldest surface is. You can see some of it's wet. There's so much heat and moisture up in the attic that it's actually wet. But if you see these signs, there's a pretty significant air leakage pathway into the roof. Cellulose turns white when you get lots of moisture and heat through cellulose. It tends to turn a cakey white color. So things to look for when you're in an attic. And I recommend people, it's good to get up in your attic. You don't have to crawl through it or anything, but just peek up there and take a look. The winter, summertime are good times, 2 different periods. Walk the roof, make sure no problems have developed or leaks. And ice damming is, like I said, has been a problem more and more, it seems like. I don't think it's because I'm busier. More people are becoming aware and concerned about the problem, rightly so, because it can be it can be a serious insurance claim, and it can also be a ton of water into a home. And so if you end up with ice damming, I always tell my clients, make sure you get the snow off the roof, get the ice drained and water drained, and so that you don't have any more buildup. That's the most important thing. We can take care and figure out what's going on later, but the most critical thing, and it can get expensive too, but is to make sure that we can mitigate any damages. That's what the insurance companies want to see too. But ice damming is a black and white issue, I tell people, because it's oftentimes, it can be lots of contributing causes. We can have insulation issues, ventilation problems, right? They can all be contributing. But oftentimes, almost always, I would say 90%, very high percentage of the time, it's air leakage, right? We have a major attic bypass. In this example, we have a flue chase with no air sealing at the top of the ceiling. And so we end up with just a lot of heat, and you can see it. This is the roof itself. It's just melting out that one spot above the flue chase. And so this is what you can look for if first frost. I tell people, take a look at your roofs, make sure you don't have anything developing. After you've made improvements, it's a great time to look at it as well. Make sure there's nothing still there. You should have a nice ice sheathing on that first frost, no melted spots or hot spots. That's what you want to look for. I mean, even the ridge vents should be fairly frosted, but if you have a little bit of heat loss and everything's venting properly, it should be okay. And so one of the best resources I found, it seems, I don't know how long this site's been available, but I found it probably 3-4 years ago. It is called the Building American Solution Center. And the reason it's so powerful is it doesn't just, in the past, we've had checklists or their guides for different improvement options for experts or professionals working in the field. But now we've actually, this Building American Solution Center through the energy.gov has developed a whole scope for different improvements. And this is just one of them, right? So there's different improvement options throughout the house, throughout the building that has these guides to them. And there's checklists, there's resources, descriptions, success pages, what success looks like as far as a completed product, whether it's insulating an attic knee wall or air sealing around these attic bypasses. But climate, it looks at different climate options and what you can do, whether you're a warm climate or cold climate, training, and then they even have CAD drawings, compliance, lists out code requirements where a lot of these issues showing up in homes there is actually code requirements for energy efficiency, air tightness, and so forth. Retrofit options, and the more page is even better. There are a list of checklists and others resources that are available for that whatever area you're looking in. And so definitely if you're making improvements to your house or hiring somebody, even it's important to take a look at this, make sure that they have the resources, the contractor knows what they're going to do, and so forth. And so a great resource. I like to reference this all the time. Visible signs of exfiltration or air leakage, right? Leaving the building and building degradation. And some of these are pictures from Fairbanks, a lot of them, because in the Arctic climates, we can see these problems differently than we get in Anchorage or the Southeast, where you get wetter conditions, right? And so in the Arctic, we can see frost forming, right? We can see it on our building, our walls, around our windows, in our attic spaces. And even this frost picture of the attic knee wall, that bare spot is where it's warmest, right? That's where the heat's actually leaking out of that wall section, and the frost is forming on the roof and inside the vapor barrier. This is another good example why we don't put a vapor barrier on two sides, right? If we had a vapor barrier on two sides of a wall, this is what can happen. And I tell people, if you have frost coming out of any area of your roof, whether it's the eave or out the gable end, that's a serious problem, right? Because what you're seeing is just the tail end of it. It's a much bigger problem inside that. For that much frost to develop outside, it ends up being a huge problem. And then exfiltration, depending on your siding, is more visible with these older homes. With cedar siding, it can really start to show up and demonstrate the extent of the air leakage pathways. And so I thought that was interesting. Air sealing windows, it's a great improvement option. It's fairly easy. This is another Building American Solution Center has a great resource page for this improvement alone. Oftentimes these older homes, these 1980s homes, 70s, 60s for sure, and some 90s homes, they'll have no air sealing between the window and the rough opening. And that's this blue area here is where cold air can come in. And the bottom right picture is an IR picture of a window with the building depressurized. And you can just see how the cold air is just screaming in behind that trim. And so to fix it, it's pretty simple, right? We end up popping the trim off, careful not to break it, and then caulking or foaming in the window, right? It's pretty simple. Great resource there. Check it out if you have that improvement. Heating and ventilation systems are complex, right? They often require a professional to do anything on them. But this is the Energy Star found that nearly half of all HVAC systems are incorrectly installed. And I have to agree. It doesn't mean that it's not functioning or performing. It just means that it's not installed correctly, right? And so this has been this has been what I found as well. There's something serious sometimes. Sometimes it's minimal. Maybe it's just a relief valve not piped, but sometimes it's a big deal related to how it's venting properly, and overheating hot water systems. I find that often it's sometimes hard to control ghost flows if it's not properly installed. And so scalding water issues, I'm trying to think of other examples of, but we'll look at a few. And so if you have problems, if you have signs of any flue signatures or any sort of ghosting on the exterior, any sort of rust or corrosion developing, that's a sign of a bigger problem that you may not be aware of. There could be safety issues. And this is the IR picture in the middle is just a boiler located in a crawl space. It's not common in Fairbanks, but you do see it from time to time in the Matsu Valley, Anchorage area. And this far right picture is a furnace and water heater located in the garage, nonetheless, which I feel is a bit of an incorrect install to begin with, but at least they're sealed up. But there are a few good resources here for maintenance checklist. Oftentimes you don't have to be an expert to start looking at your appliance and getting better educated about it. Duct sealing, huge improvements with duct sealing. We'll talk about that a little bit more. And then Energy Star's verified installation practices. And so a great resource there to make sure that your appliances are being installed properly. And I just think it's super important for homeowners to be better informed about any work that's being done on their homes, especially with their heating systems and water heaters. And so one of the biggest problems with forced air systems, and it's actually the reason people complain about forced air systems, is because the ductwork is just installed incorrectly typically. If you have in this ductwork here, in these pictures are all located in an attic space. There's some kitchen ventilation and bathroom ventilation uninsulated running through flex duct, and then there's forced air ducting running through flex duct. And if you have some of this in your attic, that's there's a huge opportunity there for improvements. Fixing those, correcting those, getting those removed from the attic and vented run in different locations. But what's true about ductwork is whether it's in your attic or in your crawl space, the duct leakage still has an impact. It might have a bigger impact because of the heat loss in the attic or because of the duct leakage, but there's still potential improvements there. And so I'll look at that next. But and what's true about flex ducting, and even whether it's located on a kitchen fan or a bathroom fan, it has a huge impact on flow. I see sometimes with low pressure systems, you might see a 20-30% difference in flow between rigid and flex. And so it can definitely impact. And also the flex ducting, especially for the kitchen fan, it ends up just building up with ice and water, right? And it's a huge restriction on flow, but it also builds up with ice and water. Even your dryer vent is a bad situation for flex ducting because these baffles inside the ductwork just start trapping lint and everything else. And so one thing about this dust and buildup on inside the attic on this right picture, it's actually indicative of what is inside the ductwork as well. When I look inside ductwork, this is what I find typically. And so duct cleaning can be really important, obviously not the outside, but the inside of the ductwork, getting those cleaned for your indoor allergies can be really important. And so when we have ductwork running through an attic, and this is true of ductwork running through a crawl space and garage as well. Same situation happens. We end up with this pressurization, depressurization. We're pulling in air from a crawl space into the ductwork and we're pressurizing the house with it. That happens often. It can lead to radon issues from a crawl space. It can lead to contaminants from a garage being drawn into the house and through the ductwork. And even with the system off, you tend to have communication and leakage that can lead to a poor indoor air quality. So duct sealing is one of the best things you can do to any HVAC or forced air system. Duct cleaning, like I said earlier, is actually a great improvement as well. So we'll look at a few pictures here. And so I've taken a few pictures in close up, and this is a forced air system, a newly installed, brand new house, new forced air system installed in Anchorage area, and it's a high efficiency condensing furnace. But so in Alaska, we still are allowed to use the floor joists for return air plenums. And what happens with the installation is we get these larger holes inside the corners at the floor joist, where it's not caulked or sealed, at the plenums, and in the round piping, the branch lines connecting to the plenum, just not sealed. And so these are easy improvements to do, especially in a crawl space. The sealant is something you can pick up at the store. We always recommend low VOC products, which is volatile organic compounds, right? So products that don't emit a lot of gassing. And then it's some foil tape, not duct tape. Duct tape doesn't seal ducts, but foil tape and duct sealant can be easily applied. It's simply just wiping down the ducts and painting on a duct sealant, but extremely effective at improving the comfort, durability, and safety in the home. Very good. And this is what a cut sheet looks, right? And these are the different joints that we have to start looking at to seal. And but a great improvement, easy to do. Filtration is important, right? We need clean air in a house, especially with people with asthma and such. And so I wanted to talk about filters. They have a big impact on your furnace performance, right? They restrict a lot of airflow. And so oftentimes we buy, at the store, we only have available 1-inch filters, and oftentimes they're not even a MERV 8. But, and so there's a difference between a 1-inch filter and say a 4-inch filter, right? And sometimes our filter cartridges for the furnace cannot take a 4-inch. We have to have special upgraded filter packages for our furnace systems. But there's a lot of options, and sometimes we have to go online to find these larger filters. The larger filter has a larger surface area, the larger pleat. And so they can have better MERV ratings without restricting more airflow. And so we can get better air, better flow, and better performance from our system. And so we have to search for these items. Sometimes I do myself. And so, and then MERV 11 is what's been recommended, but oftentimes if you're stuck using a 1-inch filter, MERV 11 is a lot of restriction. And so we need to possibly look at filter upgrades. And so if you're making improvements to a forced air system, this is one area where you can improve or upgrade. And so look for better filter systems and better flow. Fan and pump upgrades are sometimes complicated, especially for the furnace motor. But oftentimes we have to replace the motor anyways, right? After 5-10 years, these motors tend to burn up, and we have to replace them. And so there's the opportunity to upgrade, right? Anytime you have to replace something, look for upgrades, talk to your contractors. There's a resource here talking about upgrades and whether they're worth it and what options there are available. But ECM motors and PSC motors are available. They're typical in newer appliances. The difference between a 95% efficient forced air furnace and a 98% efficient forced air furnace is the ECM motor and the burner control, right? So we get better control features that allow a wider range of speeds. And so we're not just a 2-stage or 1-stage, we're multi-stage on the ECM motors, and lower electrical cost, quite a bit lower, to the point where you could actually start running this continuously and not really see the impact of the electrical cost. But again, duct sealing, there's a nice brochure at energystar.gov, and then filter replacement, duct cleaning. Duct cleaning actually has an impact. We don't talk about it much, but it not only does it have a huge impact on your air quality. If you're sneezing every time your furnace turns on, it's probably time to clean it and upgrade the filter package, and look at why it's so dusty and dirty, right? Duct sealing will fix that. But duct cleaning actually has an improvements on performance, and it's very minor in some aspects, but when you have clean, shiny ductwork on the inside, you're going to be reflecting that energy back into the air versus being absorbed into the ductwork and convected or radiated away. So But anyway, boiler upgrades include pump upgrades. There's newer pumps today that have better control features, better flow options, and you end up with better performing system overall. And the manufacturers are claiming an 80% electrical savings with these smart pumps. And then there's also the option of cleaning your baseboard, right? Oftentimes these older houses are just gunked full of hair and crowns and everything else. And so they can be just fixing your baseboard can have a nice improvement and clean up the system. The DOE energy saver recommendations for oil-fired appliances are a barometric fluid dampener replacement, right? And so after a period of time, these wear out, and these bearings, these little pivot points, there's no bearings, but these little pivot points tend to rust and corrode. You can start to have your dampener open wide, stay open, and which allows more airflow up the chimney. And oftentimes, this dampener gets overlooked, right? The technician is just leaving it where it was and not messing with it, not testing the draft of the fire. And this is where we have to really understand what their job is to clean and tune that boiler. And so this is oil-fired systems specific. Your gas systems are already designed and engineered to vent. And so this one, a barometric damper is used on oil-fired. And there's an opportunity to derate your oil burners. Oftentimes these boilers are oversized, right? For your house, you might have a 120,000 BTU boiler, but it only needs 60,000 to heat the house, or 40,000 even. And so there's an opportunity to derate the nozzle. And if this is done properly, this is where a technician's critical, right? The manufacturer's literature, the recommendations for derating have to be followed specifically with the right nozzle. And then the system has to be tuned and adjusted with the proper equipment to measure the stack and the temperatures and the CO and the CO2. And so, but then the draft of the fire has to be measured. And so there's a lot of process to this, and it can be a lot to take on to learn, but at least understand and listen and talk to or watch them as they make improvements to make sure you're getting your money's worth. And they should print off a receipt showing you the efficiency and the adjustments. They oftentimes stick it to the side of the boiler. And so we want to, and these is recommended to do annually. What I find is specific to this whole aspect of this whole section is a lot of times contractors are tuning up their boilers to burn cleanly, right? That means they only have to clean it every couple years or 3 years, right? They're dropping the efficiency down to 83%. So you're losing 4 to 5% efficiency just in order to burn cleanly, right? But if you actually clean your boiler annually and you have it tuned up to running at its maximum efficiency and it's burning cleanly still, you can actually get almost 4% efficiency out of this. And so take a look at that and try and learn about that. And sometimes it's not a bad idea to hire an independent inspector or somebody. If you're having any concerns or problems, hire a different contractor to give you a different perspective, because we all get settled into the same contractor and we get the same spiel about everything. And I find this is a sizable upgrade. I mean, sizable improvements without having to replace your heating system. You can get a sizable improvement just by watching and paying attention that your system's being maintained properly. And then modulating aquastats for hot water boilers can be an expensive improvement. They can be anywhere from $300 to $1,200, but they do offer a nice improvement. You can go from 87% to 90% overall efficiency. Did I say that right? 87 to 90% overall efficiency from a modulating aquastat with an outdoor reset. And so a lot of the high efficiency gas boilers already have this internally. They already have a temperature sensor set up for the outside, and they have the control features to do that. But on an oil-fired boiler, you have to typically either there's plug and play modules that are programmed to go into the boiler now, or you have to add on an aftermarket aquastat. And some boilers like a Baderis has a Logomatic controller for this. Other boilers you have to add on this modulating aquastat. And it has outdoor weather sensors. They call them reset controls to lower the water temperature. And then they have warm weather shutdowns, vacation modes, and hot water priority features. So great improvements to do, look into, and see if your home needs. I like to throw this slide in because we can talk about the comparisons between fuel and gas. There are areas around the state that are looking at converting into gas, and it can be expensive, right? So I've priced this out for Fairbanks because they're going through this right now, and Homer's done this in the past. But and so it's just a comparison between fuel oil in Fairbanks and natural gas in Fairbanks. We end up with $31 per million BTUs for number 2 oil on an 87% boiler or furnace, and then $21, almost $22 per million BTUs for natural gas on a 95% efficient. So you get about a 30% savings in upgrading to 95% efficient boiler or furnace. That's a nice improvement. And so if you're spending $2,000, $3,000, I'll make it simple for myself, $3,000 in fuel oil, you could see $1,000 savings from that upgrade. And one other aspect of this I'd like to point out too, if you had a oil-fired boiler, you were going to upgrade from to a natural gas burner, there's a drop in efficiency. And so oftentimes it's a 5%-ish drop in efficiency. And so there's still some savings there to be had. But you wouldn't, yeah, so it's a much cheaper upgrade, but you still see some savings, probably about almost $5 in savings. Hopefully that's helpful. These are important questions. If you're making improvements, your energy auditor can really help with this and identify, is there a payback here? Is this worth doing? How quickly will this upgrade pay back with the cost of doing it? It's probably a good time for break. Does 5-10 minutes sound good to everybody? Does everybody feel like a break? Let's take a break, I think. So let's come back at 6:30. Nice 10 minutes. Go get a cup of coffee, and if anybody has any questions, this is a good time for that too. Let's take a look at chat. 5 minutes. 5 minutes are good. Okay, we'll do 5 minutes. That's fine. Hopefully we don't miss anybody.
Hi there, I have a question.
Great. Yeah, shoot away.
Oh man, I hope my phone wasn't unmuted this whole time.
No, not at all.
Oh, thank goodness, because I'm all fighting with diesel fuel, and I'm glad it wasn't. I'm glad it was on mute. Anyways, um, I'm looking at building a new house this year.
Okay.
What's your opinions on products to use or a great place to start for energy efficiency? I've been talking with Alaska Insulated Panels about SIP panels. What do you think? And what are good options out there?
Oh, those are a great product. Those are a great product. And, any product you end up going with, whether it's fiberglass, blown cellulose, or SIPS panel home, make sure so often we get into the rush of building something, we don't actually follow the directions. And so anytime I've seen problems, especially with SIPs, it's a kind of seems simple just to throw them together, but the following the directions is critical. It seems simple, right? But that's the biggest problem I see. Even with blown cellulose, right? If you were just to build a more standard wall construction and use blown cellulose or even fiberglass, it seems simple to just install in fiberglass, but it's the details that really matter. And it's the install that really matter. And so in cases where SIPs have been problems, it's just because they haven't been sealed properly, whether it was a roof or wall. I've had a few custom homes with a SIP type wall, and it had horrible leakage, and they weren't able to heat the house, quite frankly, for a couple different reasons. But so we have to be careful and attentive to making sure that we're sealing up those wall sections, those building corners, and those roof lines. And so so Energy Star has a pretty cool program for new construction. There's a checklist involved. DOE has an Energy Star, or DOE Zero Energy Ready Homes has a program that's well outlined, and you don't have to get certified or follow every detail, but you can get a lot of resources through those programs that can help you build a better home. And then, an energy rater can help you with energy modeling the house to make sure that it at least complies with the building energy efficiency standard, and then help you size your heating system. You're in Houston, I think you're right? Right?
Yep.
You said,
Yep.
yeah. So you might be going with a monitor or Toyo, or maybe a forced air system, but if an energy rater can help you size the systems and make sure you're gonna and tell you how efficient your home's going to be, and if there's help you size your ventilation, maybe even help you with some of the design aspects of that.
Have you had any experience with in-floor heat with using SIPs?
Yeah. It's in-floor heat works with any building design. The biggest trick with and it's a code requirement too, is to insulate underneath that heated floor. Whether it's a heated slab or a heated floor on the second floor, they all need to be insulated underneath. That's a key issue. And now, and in cases of that example I was talking about with a SIPS home, is a large custom post and beam SIPS home. They didn't have insulation underneath the radiant floor, and that was a big factor in their comfort levels in the house.
Really? Was it a SIPS floor?
No, it was a standard floor, 2x12s, right? But they put in heated floors, and then just didn't insulate it.
So a SIPS floor is insulated, and that counts, right?
Yeah, you have to use a different floor. You can do Gypscrete type system, or you could do, there's newer systems that have the floor inside of a layer of wood. Right? I don't remember the name of it, but they have some. Good questions.
Nice. So another thing they were talking to me quite a bit about was acoustic sealant. Is that is that good? Is that the stuff for sealing up wood to wood contact?
I would have to look at the manufacturer's instructions again to see what they recommend. If that's what they recommend, the manufacturer, I would use that. But acoustic sealant is typically used on vapor barrier systems.
Right.
Right. There was
Well,
one
last
other.
insulated panels, they said every wood-to-wood connection they use glue, foam, and acoustical sealant.
Oh, that makes sense.
Yeah, because they said it kind of makes a gasket, if you will.
Yeah. There was one other question about baseboards. Great question there, Adam. Thanks a lot. And the baseboard question from Arian.
Thank
Glover,
you.
you had a question about just vacuuming your baseboard, and that's simple, of course. That would work great, and it's not going to see a huge improvement. But what you will do is start inspecting your baseboard a little closer and find leaks, right? And that great plug by John Parcel about the FLIR One. They do have some cheaper FLIR cameras that could be helpful for homeowners, and so maybe you know of somebody that has one too. And so if you have a tighter house, you can turn on kitchen fans and bathroom fans and create a negative pressure, or wait till a windy day to see some of that air leakage too. Those are great tricks. Water heaters are a big part of our energy use, and they oftentimes are a big part of the comfort in a home. Whether it's too hot, it could be a safety issue too. It could have scalding temperatures. I see that from time to time with systems just not protected or controlled properly. And so if you have those types of problems, you want to dig into them further. There's a lot of energy loss. When you're having your hot water systems I've seen 180 degrees on domestic hot water system, which is instant scalding, right? Even 150 is like in 3 seconds. So we want to make sure we protect our elderly and our children and so forth. But when we're making upgrades, there are lots of options for water heaters. And I have a web page here that is great. It's energy.gov. They've got a new infographic and projects to keep your energy bills out of the hot water. And so what's nice about this is they actually go in and break down different systems available, right? Whether it's storage, tankless coil, and indirect. They start looking at the life expectancies, cost, pros and cons. And so they could be helpful in making decisions and talking to your contractor and being better informed overall. And so I wanted to share that with you. And so the energy factor is how we calculate the energy efficiency of a water heater. It's a complex calculation, quite honestly, but it's how you can compare one water heater to another, right? The energy factor of an on-demand gas appliance can be as high as 0.95, and which equates to 95 efficiency, where indirect fired water heater off a boiler could be anywhere from 80 to 85, depending on how efficient your boiler was. And so, oops, sorry, 2 slides. And so tips for reducing your water heating bills, I've got a few. This is just a common sense ones. Use less hot water, low flow fixtures, faucets, shower heads, turning down the temperature to 120. I like 125, but it's a personal preference maybe. Be careful about getting that too high or too cold. Too cold, we end up with Legionnaire's disease potential, right? We end up building up bacteria. And so that could be a problem. Fixing leaks can help. Doesn't seem like much, but it adds up. And cold water usage versus warm water. The next slide, this is typical of a 70s, 80s home, maybe some 90s homes. They have a tempering valve that's common for toilets, right? We start heating the water that goes through the toilets, and this just amounts to hot water flushing down the toilet. It's an old carryover from the 70s and 80s where we didn't have good ventilation in our bathrooms. And so they always are problematic. They always fail, and they always end up with hot and cold water sandwiches in your shower to just really hot temperatures down the toilet. So instead of upgrading or fixing, just remove them. That's the recommendation. If you have some condensation problems in your bathroom, or even if your mirror's is fogging up, anytime you shower, you need better ventilation. There's something not flowing there. There's not enough airflow, and so we need to increase or improve the ventilation. Low flow shower heads, low faucets can make a big difference. Upgrading washer machines and dishwashers can have a nice payback as well. It's part of the payback and energy savings with those types of appliance upgrades. And so those are nice. There's a WaterSense program. If you really wanted to dive into this and start tuning up your hot water system, there's a WaterSense program with EPA that has a ton of resources in it for how to squeak out the efficiency you want. And so there's a few other things. Insulation, we'll talk about it next. Here we're going to talk about, oh, I'm sorry. Patricia, go ahead. If you wanted to jump in, please.
I just had one quick question, and that is that there is a thermal imaging camera app for an iPhone. Do you think that something like that would be a good device to check at least a few small things in your home?
No, that's a good question. The app isn't, I don't think that's a good option. I wish it was. It's not an IR camera. And so it ends up being kind of a false IR. I don't think it works well. They do have $300 range cameras for people, and they do have that. There's a FLIR One camera add-on that can be plugged into the bottom of an Apple phone or an Android, I think too. That's even a little bit cheaper than that. So those are actually thermal cameras, right, that are tied into your phone and work. And so the other the FLIR One is that model, but then they have a few other models that are in that $300 to $400 range that are pretty decent, honestly. These smaller cameras now, they're about that size. They used to be this big, and of course now you're quite a bit more money. So those definitely come down in prices. And if you have a larger project, I see more and more contractors and people picking them up. So definitely there. Great question.
So there might be a way to borrow one or something like that rather than everybody get one.
Yeah, I haven't seen, yeah, of course. I think that's a great approach, right? A community camera would be awesome, really. Yeah, totally agree. Good question. And so hot water heaters have this inherent problem that I've seen where it turns into a high energy cost, especially with electric water heaters. And so if you have a water heater in a basement or a first floor and you have a floor above it or 2 floors above it, you can get strong convective currents carrying hot water from the tank up through the piping and then cooling coming back down. And it's because of leakage inherent in shower valves and other valves. And it can be worsened by hard water, right? So water softeners can really start to save you money in some of these aspects with leaks and so forth. But, excuse me, our water heater manufacturers say, hey, we need a heat trap here to stop this natural convection through this tank and through the piping. And it entails just a drop in the hot water pipe. In this picture, they show a drop in the cold water pipe too, which is fine. But creating that trap prevents the water from convecting naturally up through the piping system. And that can turn out to be a pretty decent savings if it's the problem, right? And you can test this, right? If you don't use your hot water for hours on end and you go down and you feel the pipe, if it's still hot, you might have this problem and it could be worth upgrading. There's also mixing valves where you can incorporate and it's a code required safety device that protects your hot water from scalding temperatures by connecting cold and hot. And there's a specific thermostatic valve that's used in this application that can help improve performance and protect the safety of the user during scalding conditions. Because all it takes is for this valve to fail or thermostat to fail, and all of a sudden we can have a runaway hot water heater that starts to overheat. So hot water recirc systems were quite the rage back in the 2000s, 2010s, and they're great for improving comfort and performance. They do cost to run, right? We have pump cost and also heat loss cost, because so often our piping system is uninsulated, right? Our hot water system is uninsulated. Our cold water pipes are uninsulated, especially in older homes, but even some newer homes. And there's a lot of heat loss through the piping. And so for a pump to run continuous, that ends up being similar or worse than this problem, right? We end up with this problem because of natural convection. But when we turn on a pump and we run this continuously without the proper controls, we have a bigger problem, more heat loss. During the summer, when we're not even utilizing the heat, we end up with a baseboard section of pipe running through our house for our hot water system. And so we want to make sure that there's controls, timers, and I have a couple of pictures of those. And so we can have timed controls, swirling comes on a certain period of the day, or we can have temperature controls. And so reducing that on time, reducing that runtime can make a big difference if you have those hot water research systems. And then tank and pipe insulation, right? So piping insulation is a no-brainer, right? It is an improvement in comfort, it's an improvement in performance and energy savings. So it's not terribly difficult to do. It is tedious maybe, but if you can insulate your mechanical rooms and your crawl space piping locations, if you're doing new construction, insulate all of your piping, you'll see a difference there in condensation problems and heat loss problems, and the water will just stay hotter naturally. But if you have an electric tank, this was a old carryover from these older 70s and 80s water heaters, right, where they had very little insulation. The recommendation was to add a fiberglass blanket, wrap it around, and insulate it. I don't think that's a good recommendation anymore. The water heaters are past that age, right? The tanks have more insulation naturally because of these energy requirements. And so it's not a good recommendation per se. If you have an older tank that could use more insulation, it's time to replace that water heater. It's not time to add more insulation necessarily unless you can't afford otherwise, and then that could be an option. But for the most part, these newer tanks have more than enough insulation. The manufacturers actually recommend not insulating it, so because of just safety aspects and to make sure that nothing overheats there. So keep that in mind. I wanted to talk about our electric bills next, and this is just good information about our electric bills. A lot of people may know this already, so I'll kind of skip through it, and it's explained on GBAs, or if you live in a different part of the state, you can visit your utility company and they'll have information about your utility bill as well. But customer charge, utility charge, fuel and purchase charge, and regulatory charges all show up on our electric bills, right? And so we look at this bill, we pay the bill, and what information do we get out of it, right? All we're worried about is this wattage usage, how much usage we're using each month. And it's hard to keep track of in this form. And so I try and encourage people to move towards a form of, this is called Smart Hub. And Smart Hub I use it I'm in the Matsu Valley. I use it for my electric bill, and I can look day to day on my electrical usage. I can look at monthly and yearly. I can compare. So it's a powerful tool to identify problems. And I can see a usage jump up and down day to day, depending on what I'm doing and what I'm using. And so that can be very powerful. And we can compare. And you can do this yourself, obviously, right? You can start to graph your monthly bills, and they can be useful tracking month to month. But when we're looking at it day to day, it can be quite powerful, especially if we're testing systems and we can start to identify problems with our electric bills. And I actually have some monitoring systems we'll show you later, right? And so we talked about lighting earlier. I've got this amazing lighting handbook retrofit guide I found through the Forest Service, Department of Agriculture, and so I'd like to reference it. Lighting upgrades they're a small percentage of your energy cost, but they have a huge impact on your life, right? We've all gone through this change of going from incandescent to CFLs and LEDs, right? And we've all stumbled through it. This handbook is very helpful. It actually informs the reader about the terminologies, the different applications and colors, temperatures, and lumens and efficacy of the lighting. So it's worth a read. And if you're planning on doing lighting upgrades, it can be helpful. It's got not only the definitions, I wanted to talk about definitions too, because sometimes it's not always easily understood, but voltage and your ampage, right? We have 120 volt systems on our electrical systems. And our amperage is how much power is being pulled through the electrical wires. And so volts times amps equals watts, and energy watt hours is what we're paying for, right? It's how many watts over a period of time. And so a 100-watt bulb over 10 hours uses 1,000 watts, or 1 kilowatt hour. That's 1,000 watt hours. And so that ends up being 28 cents, right? So 10 hours of a 100-watt lamp is about 28 cents with all the fees. right? But so this guide has this, even if you wanted to figure out if this was cost effective or what was most cost effective, we can do this by hand. I haven't found any good calculators, but this was simple and user friendly and very informative. And so if you're looking at making improvements, this could help make a lot of sense with the energy savings and the payback period, if you're worried about that. But what's the cool thing about lighting is how it can change your life, right? We can start to change the colors in our house, right? We can start to change the lighting in our house to where it impacts our moods and our environments. And it does, and I'm just talking about the two basic color changes going from, so 3000 Kelvin versus 5000. 5000 would be that brighter white light, and it equivalents to a daylight, right? It's a middle of day temperatures, middle of day colors when the sun's highest in the air. And that invigorates us and improves our mood. And then the 3000 temperature is perfect for that nighttime setting or early morning setting, right? That when the sun is in the sunrise and sunset. And so we can start to change the environment in the atmosphere in different rooms, and using some of this information. And in my kitchen, I was lucky enough that I bought this home. It ended up having 3 different lighting types in the kitchen area, which is just amazing because it allows me to light up the cooking area with bright fluorescent that are about 5000 and temperature. And then it has some recessed lights that I can turn on for that are at 3000 Kelvin. And so it really can change the ambience in the room. And then it has more of a nightlight fixture over the kitchen sink. And so you can change your bathrooms and your laundry rooms and your bedrooms for these different temperatures once we start to get better informed about these color indexes and the impact. And we can also look at lighting controls, right? And not every control is perfect everywhere. Dimmers don't work well in some areas where timers and photocells work really good outside. And the motion sensors are great at outdoor lighting, bedrooms. I'm sorry, let me close this down. And, motion sensors are great outdoor lighting, bedrooms. Maybe not so much in bedrooms, maybe. Garages are pretty common. I see those a lot. Closets, if you have a closet. Laundry rooms can be useful sometimes. Timers are good on vehicle plugins, bathroom ventilation. So anytime we are adding a control, whether it's a bathroom ventilation or a lighting control, we're reducing the on time. Even a hot water recirc pump, we're reducing that on time and run time and saving money and improving the performance of the system. I think the biggest savings you'll see is typically outdoor lighting, where you're putting in LED lights, replacing halogen bulbs or higher wattage fixtures with LEDs and photocells. Motion sensors are great for security as well. And so, and some of these older lighting fixtures can be pretty decent savings. Let's go to the next one. Appliances, right? Appliances come with 2 price tags, Energy Star says. They have all the different appliances available on their website to look at and compare. And so you can start to find appliances. But I think we've all seen the energy guide sticker labels on our refrigerators and washer and dryers and so forth. But I think what's important is when you're looking at this label, is it's the calculations used for the $67 estimated yearly operating cost are set at 10 cents. And so in Alaska, Anchorage area, it's twice that. Fairbanks 3 times that. In some of the rural areas, it's 4, 5, 6 times that. So you have to make sure you're catching that, right? You might have a brand new, an older appliance, sorry, that you need to replace, and you're looking for savings. You're like, wow, it's going to be 3 times this. It's going to be closer to what is it, $180, $200 a year to operate this in Fairbanks. And so there's some appliance energy calculators at the Department of Energy, and there's also a fridge calculator. So, and I'll show you how you can actually figure out what your fridges use. And it's pretty simple. It's a great project for kids to learn about too, but I'll look at that next. And so we can compare as is versus a new appliance and what it might actually cost. And so estimating appliances and home electrical energy use, we can review the energy guide. We can, so backing up a little bit, appliances account for about 13% of your household energy. refrigeration, cooking, laundry, and so forth, right? And so we can look at the energy guide, we can look up the older appliance if it's not too old and find out what it might have used. And then we can also use an electricity usage monitor, get readings of how much electricity an appliance is using, and I have a couple examples of those next. And then calculating energy consumption and cost using formulas on the different websites and calculators on Energy Star and energy.gov. And the last one I think is the best option, and I'll show you what that is. So when we start to monitor energy, it's the same thing as if you're weighing yourself every day, right? You're going to naturally start to lose weight, I think. And if we're monitoring our energy use, we become aware of it, and it becomes a powerful tool to identifying waste and problems in our energy. Whether it's electrical is the easiest to monitor, but we can do oil and gas, obviously, too. But in this example, we have some different products we can use to monitor electric. And so even if you just wanted to do your refrigerator to see how much that was using on an hourly or annual basis, this Belkin model is probably the simplest. It's got a nice long wire, so you can plug it in from behind and use it up front, input some numbers for how much you pay a kilowatt hour, and start to get readings there right away. The kilowatt's an old standby, and still great for calculating our energy use for different appliances. And so these are great projects to look into if you're trying to figure out where some of the energy is going. And it's really informative for kids. You know, it's so difficult sometimes to get kids to turn off appliances and stuff. And so this can be really educational. But there's some newer products. This TED Pro Home is an older product that helped us monitor electrical usage throughout the house for the whole house, and then also for different plug-in loads. Or major appliances. And so the current cost came out probably 10 years ago, maybe more. And so that was a great product that did well. And then the Nereo is a newer product that's come out recently. And these wires and little block here, they actually clamp onto your electrical wires, whether it's in a panel or it could be a plug load or whatnot. You can actually set these up to monitor electrical usage for each electrical circuit in your breaker, or just major ones. It's typical just to do the whole house, and then major circuits like if you had a jacuzzi or a forced air system you wanted to measure, or a well pump. They can be great for identifying problems and helping with that. And so one of the best things you can do if you're trying to get a hold of a high electric bill and figure out what the problems are at, that can be very informative. And I like informing people about vampires cost, right? We have you have standby cost to appliances, right? Your cable box, your stereos, DVD players, computers, and so forth. When we're not using these systems, they go into sleep a lot of times. Most of them do now, but they still are using energy. And so that can add up to quite a bit. And so we tell people, if you're, it seems redundant, but if you can put it on a switch, right? If you can turn off a breaker, I do this in my living room downstairs for the kids. I hopefully have them trained now, but they turn off and on the power switch, and it turns off all the gaming consoles and cable boxes, TVs, all of that. So we're not on standby anymore. We're off, not using any power. And this is obviously for plug loads on a vehicle when you're keeping your vehicle warm. Great to have timers. I use this conserve socket. I use this for my kids when they're younger, where they would have night lights and they would stay on for a certain period of time and then go off. And then and even the conserve power switch I use in my coffee pot and microwave and stuff like that, so I can easily turn it off without having to pull it in and out. And that's worked well. I haven't had any problems with that. And so these are great ways to start saving and making your house safer, I think. Well pumps are big loads. This is a commercial well pump, but I use it as an example. And a residential well pump operates at 230 volts and 12 to 15 amp draw is normal. And so it ends up being a decent load. And it can it can actually start to run into problems, whether you have a check valve problem or a wiring problem, a grounding problem. It could have a list of problems that can start to increase your electrical usage to the point where the pump is just running continuously because it's not maybe a check valve check valve failures. So that monitoring the electrical usage on your well pump can be really informative to identifying problems with the well pump, where you can catch maintenance issues before they turn into year-long problems that end up being expensive to repair and whatnot. So great to keep track of that item. Big purchases. There's other loads in the house. Jacuzzis are big loads, typically $50 a month or more, and so monitoring that can be helpful. Identifying issues, security systems, heat trace can get expensive, right? Insulation is cheaper, I always say, and I like heat trace as a backup, right? Whether you're putting it on your roof or on a piping system that's exposed, I like to have lots of insulation and then heat trace as a backup, or some level of protection. There are control features to make sure we're not freezing up, but we're not overusing our heat trace and running up our electric bills. Faulty wiring, domestic hot water recirc systems, we talked about earlier. Outdoor pets, heat lamps, watering stations, and wire fences, they can get expensive, and so improving that is beneficial, but it really takes some. You kind of have to figure out why is it using so much beyond just. And so it gets tedious to talk about it right now, but those can be areas where you have a lot of electrical usage. And then holiday decorations, of course, we have LED lighting now, most of ours, and so upgrading those or utilizing timers and so forth can be helpful. Indoor air quality is really important. Ventilation it ends up being I don't know, how do I say this? I guess the contaminant controls and moisture loading drive ventilation, right? So the more contaminants we have in a house, the more moisture we have in a house, the more ventilation we need. And so in order to improve and to achieve performance with our ventilation, we need to reduce contaminants, reduce the moisture loading, right? And to maintain good indoor air quality. And so it's a balancing act between those issues. And so when I come in and to do evaluations on ventilation and indoor air quality, I'm looking for the contaminants, I'm looking for the moisture loading, and I'm looking for ways to mitigate that. Obviously, if we have people showering, we can't stop that. And then there's performance issues with how the systems are ducted, right? You could have a bypass on the roof. This is that bottom right picture. We have a bypass where that lot of the moisture and heat's not going out, it's just going up the roof line and rotting out the roof. Right, or you have a bathroom fan. Oftentimes, sometimes you have a bathroom fan venting out underneath the eave. Well, all of that moisture and heat being vented out just goes right back up into the attic, and so those are not typical. Those are not recommended. And the roof venting to the roof is probably the second best way to go. I don't like doing it as best practice. The gable vent, the gable wall is the best practice to vent out, because we don't end up, even this year, we ended up with almost 4 foot of snow in some locations. If you bury this roof vent, you end up, everything above it has to melt and drain down, and it can create ice damage itself. And so roof vents aren't ideal, but sometimes we have to do it. And so when we look at attic spaces and bathroom ventilation, I have to say that almost, I used to say 40%, 50% of the time, there's at least one bathroom fan not venting to the outside, right? And this is what happens, right? We see flex ducting that's come apart. It filled up with ice during the winter and then came apart from the attachments, and it's just venting into the attic, or it never was installed. Oftentimes they're just not installed to vent to the outside. Or dryer vent. I actually found a dryer at least once, maybe a couple times, with venting to the attic. And so we want to look for this type of stuff, and we want to make sure we get this stuff properly vented to the outside with rigid ducting. It's super important for the durability of the attic space or roof, and also the indoor air quality. And so these are some of the problems we want to look for. And one of the best things that's you could do as a homeowner is simply turn on your bathroom fan and go outside and make sure the damper fully opens, right? If it only partially opens, it means there's an obstruction and flow somewhere. In this example, I have we took apart some venting in a basement, and it had a bee's nest completely blocking the flow, no flow. And so it's not uncommon to have low flow conditions or no flow conditions in some of these older fans for whatever reason. But that simple verification where you're going outside and verifying your damper fully opens it's as part of a BPI testing standard, right? It's part of the energy audits work to make sure every fan vents to the outside. It's super important and easy to do for a homeowner just to verify. And once you realize the one fan in the house that's super important that doesn't vent to the outside, it's easy to fix, right? I found dampers painted shut, super easy to fix. It took 10 minutes to set up a ladder and to get those unsealed. But the homeowner had gone 10 years, and I'm ballparking it. I think it was about 10 years they went with all sorts of moisture problems. They had spent a lot of money adding an HRV system when all it was is when they painted the house last, they sealed up and painted the damper shut. So these are simple, easy to fix problems. We just have to identify them, and that's the trick. And so the newer bathroom fans, not only do they bring the bathrooms out of the 80s, they're more efficient. They use a lot less wattage. They're quieter. They're rated for continuous use, and you can implement controls, right? Humidity, motion, and the best way to ventilate a bathroom is low flow continuous. It ends up being a whole house ventilation approach, where we're doing low flow continuous in multiple bathrooms and maintaining indoor air quality. And so forth. HRV, ERVs, and then there's a CERV that's available today, and they get a lot of promotion. HRVs or ERVs are a great thing to have in a house. They're expensive. They can be anywhere from 6,000 to 10,000 depending on the home and the size and so forth. But they do bring in fresh air, and you can filter them, and you can do it. So it's a great improvement in a home. They tend to not, I don't typically recommend them as a go-to item, right? It's more important to make sure you have they call it local or your spot ventilation in your bathrooms and kitchen. Make sure you have good ventilation in those places first. And you oftentimes don't really need to start getting an HRV unless you start tightening up your house below 2 air changes per hour. And so it's an expensive option, but like I said, it's one of the best things you can do to a house to bring in fresh air for all the occupants. But and the difference between an HRV and an ERV is they both transfer heat, but the ERV transfers both heat and moisture, which is hard to do in the Arctic climates. You can't hardly do it in Fairbanks or northern climates. They tend to work a little better in Anchorage, Kodiak, and Southeast for ERVs. But the CERV is it's a whole different system. It actually uses a heat pump, and so it recovers more of the energy from the exhaust air, and so you end up with a much better performance, and you end up with you can actually start producing heat with its heat pump. And so it's a bigger system, more expensive, but it's a nice feature if you can afford it and fit it into your house. Combustion safety is super important. It can be a serious contaminant in a house, a carbon monoxide that is, and pollutants from a wood stove, or even garage pollutants from vehicles and so forth. And so it gets complicated a little bit, but it's important to talk about. A wood stove can actually backdraft. And picture number 4 down here is a wood stove in the basement. That wood stove can actually backdraft the water heater over here, and you not even realize it, right? Your carbon monoxide detector upstairs in the bedrooms or near the bedrooms wouldn't even be going off necessarily. And so it can be important to have tested. An energy auditor could do this test during an energy audit or come out for specific testing if you wanted them. But when we tighten up our house, we need to make sure we're replacing that natural ventilation with mechanical ventilation. And when we do that, now we're creating a negative pressure on the home, right? This is where an HRV has an advantage because it actually creates a balanced flow, right? You have supply and exhaust balanced out. It's designed to be balanced. It doesn't always turn out to be balanced, but it's designed to be balanced. And that can prevent this negative pressure caused by exhaust fans. And so we just have to be aware of combustion air needs to make sure we have adequate combustion air for our combustion appliances. And to be aware that if you have a wood stove, you may have seen this backdraft condition where you have a kitchen fan running and you start pulling in fumes. And I tell people, if you smell smoke, there's carbon monoxide with it, right? I've seen wood stoves produce a lot of carbon monoxide, so we have to be aware of that. If you have a failing appliance, a water heater or furnace, you can have, if they're failing as far as the combustion inside the chamber is failing, you can start to have high CO levels and life-threatening conditions. And so for combustion safety, it's important to have your house tested after you do major improvements and major upgrades, bathroom fans and kitchen fans, to make sure you haven't created an unsafe problem. But also, I always recommend digital CO detectors, and I talk about that a little bit, and so we'll go over that then. And so there's lots of great resources for this, and if you have questions, feel free to Cool Climate. One of the things at Cool Climate I wanted to mention too is they have funding now to answer questions if people have questions for kind of building issues, or I think there was questions about SIPS panels or combustion safety. Definitely use Cool Climate. They're a great resource. They have some great consultants on staff. Combustion safety is, there are lots of visual signs of combustion safety problems. And so I wanted to point these out. All right, if you have exposed chimneys, you may have potential backdraft conditions, and it can occur at certain times of the year. Or it could, in this example, this unit heater, it's a gas unit heater in the top right picture, it could happen continuously, right? And so this appliance wasn't able to draft properly at all. And so this dark staining on the front of it is a clear indication of that. Some corrosion and sooting on the face of this barometric damper is a clear indication that it's not drafting properly, and it wasn't. It just wasn't set up properly. And so there are typically clues to combustion safety problems, and sometimes there are health symptoms associated. So learning about the health safety aspects or the symptoms associated with carbon monoxide poisoning are important. And digital CO detectors are important. I'll show you in a couple slides. I wanted to talk about this one. This was this happens with any combustion appliance that starts to condense inside the flue, right? When you have an appliance that's drafting up a chimney, it starts to condense and cool off. We can end up with condensation and corrosion over time. And this happened to be a homeowner in Anchorage that ended up going through the rebate program and replaced their heating system and found this major bypass in the flue. And I've seen this in oil-fired appliances in Fairbanks and in Anchorage. So it's common anywhere in any type of appliance. And so have your systems inspected. It doesn't have to be, the manufacturers and the recommendations are typically every year as part of the service, but at least every 2 to 5 years at the very longest. And then indoor air quality and cooking, right? And so gas appliances especially, but even electric, there's been studies to see how well do our range vents ventilate. And so even a properly installed range vent doesn't necessarily remove all the contaminants. And so we have to be aware of that. And sometimes it's difficult because we take it for granted that everything's being vented out. But the Lawrence Berkeley National Laboratory found that it wasn't. And at these conditions, the conditions inside the kitchen were outdoors, the EPA would be cracking down, they said in a statement. But since it's in people's home, there's no regulation requiring anyone to fix it. And so kitchen ventilation, oftentimes I find problems with it. It's not performing, there's no flow. And so an energy auditor, you can find this out too the same way. If you wanted to do the testing yourself, you have to find the dampener outside and make sure the dampener opens up when the fan turns on. That's a clear indication that it's either working or not working. And then if you have a window nearby, cracking that or leaving that open during the ventilation can dramatically help and improve. Having a hood that's deep enough that goes over the entire range is important, they said in the study. And so, but running the kitchen fan while you're using the oven, especially, but also anytime you're cooking, can make a big difference. And so this is where we run into trouble too. We have exhaust ventilation, and we have combustion appliances downstairs. So one could be backdrafting the other. In that earlier picture, we saw where the kitchen fan and so we don't always need 250 or 350 CFM in a kitchen range. We need to have the fan on and maybe a window open, but we can also monitor the air quality around our kitchen. I use this in my kitchen. I use a digital CO detector, and it doesn't, there are recommendations on where to put CO detectors. They want them outside bedrooms, just like fire alarms, typically 10 to 20 feet, depending on the monitor you have. But I stick this digital CO detector right in my kitchen, and it helps me identify low level conditions and habits that, and so oftentimes we develop habits of cooking and no fan or whatever situation. And this is a reminder for me to turn on the fan. And I use this, you can use this type of monitor anywhere. I tell people to put it where you can see it, and you'll check it from time to time, because you can actually start to identify garage contaminants infiltrating into the house, or a backdraft condition with a wood stove or a water heater. And so keep it where you can see it, and keep it where you can check it periodically, and identify low-level conditions before they become dangerous. And so you check it as often as you need to or want to. And if you have low CO levels, it's oftentimes you'll see 13, 20, 60 sometimes, no alarm going off, and you can find this on the peak levels. Then you can start to dig into, where is this coming from? Is it a combustion appliance? Have somebody do the combustion safety testing, or look at, start parking outside and see if this number goes away, or is it part of the cooking that's causing this? And so these are very useful tools to identify these problems where we're not going to get an alarm, but we're going to get low levels. And then an energy auditor can help identify problems. They have special equipment. Your contractor, heating contractors have combustion analysis equipment that can help identify this too. And then if you have an alarm going off, the recommendation, of course, is to get outside, and you may need to call 911 to figure out what's going on. They'll come in and make sure the house is safe, so you can go back in, and then you can start to dig into what's failing, what's causing the CO. So be aware of that. Be careful of that. Wood stoves, I've had a few case studies where people have used a wood stove as a primary heat source in a cabin, but they also had a radon system, was one example. And that radon system was actually backdrafting the wood stove. It's a weird scenario. And so it ended up being a life-threatening condition. A lot of high CO level conditions that were developed during that case study. But a wood stove needs air, and that's oftentimes the biggest problem, right? When you have an exhaust system creating a depressurization of a tight house, you can start to backdraft this wood stove. The manufacturers recommend, and the Building Energy Efficiency Standard recommends, direct venting this appliance, meaning you're pulling your air directly from outside, and you have your chimney going straight up outside. And so we're pulling air from outside, we're direct vented, we're sealed, we're tight, and the only chance for leaking is through some small penetrations or through the door. And so we can start to control that with relief air if we need to, or opening up a window. And it's a wood stove has a big impact on air quality. It's important that it's burning cleanly and getting lots of free air from outside, just because of the particulates in the benzene. There's been some studies showing that there's an increase in particulates in the house with a wood stove. So I like wood stoves a lot, but we have to make sure we're using it properly. And then as another contaminant, radon is something we can't smell, right? We can't sense it, but the numbers are there. We're seeing radon levels. This is an older study from 1990 to 2014. We had results coming in from all over the state. You can see you might live in, there was somebody from North Pole, Saldana. There's different numbers here. And so these numbers on the far right in the red are maximum numbers they were reported. And so we see some very high numbers, and then we see some more median radon levels from different results. And so not to alarm you, but these numbers could be in your house, but we won't know until you test it. And so they have some new systems for that. I'll show you a couple monitors. You can monitor your radon levels in your house. It's much easier today than it was 10 years ago. The EPA has done a lot of education and outreach for lead, right? There's a few homes in Alaska still that were built before the 1978. And so if you have a home that old, you should be aware of lead paint and lead dust as a particulate. And so be aware of the potential or the requirements for lead paint, right? And so there's some resources there through epa.gov. And so monitoring, there is a lot of new products on the line, but there's even Radon Eye is pretty easy to use. It has a phone app feature, so you're getting live readings. And there are other monitors you can use for carbon monoxide, carbon dioxide, which is what we exhale, right? And then volatile organic compounds is a great product to look for. is a great chemical to look for in a house because it has a real impact to our health and our cognitive health. And then particulate matter, right? Fairbanks has gone through this a lot in the years past with PM 2.5 and PM 10. We can actually start to monitor those. These are good things to monitor in a house, especially the radon. And so these are some of the older models that there was a study done for low-cost devices, and the Foobot, I've actually had one of those. It worked great. I don't know if you can still get them anymore today, but one of the things, it's been replaced by this Wave Plus, and it has it can read VOCs, CO2, humidity, temp, and radon as well. And so it's got a phone app feature. It could be very powerful in identifying problems, and especially as we make improvements, right? As we tighten up the house and make the house more energy efficient, we can oftentimes create radon conditions because we're using exhaust ventilation systems. So we need to be checking that and making sure that that hasn't developed. And maybe it's just a low level, or maybe it's spiking at different times of the year and different periods of the day. And so keeping track of that for your indoor air quality is super important. And I've gotten through everything. And so does anybody have any questions? I kind of jumped right to the end, guys. If you have any questions, now's the time. We can talk about anything and go back over anything you have. That Kevin had a good point about the old toilet and tank condensing. If we remove the tempering valve, that's a great point, Kevin. It can happen. And so the fix to that is a good bathroom fan. And so we need a good bathroom fan anyways, but that is one way to combat that condensation problem on older tanks. And they do have insulated tanks. I've seen those, installed those as well. Yeah, I didn't talk about the slides. I think they can be, absolutely. Jamie can send that to people as they need, just for resources. That's why I
Yes.
try and put everything on there. Thank you, Jamie.
And I will say, I think we send the slides and the video out, and that
Perfect.
goes to everyone who's signed up, regardless of whether or not they showed up tonight. So it'll be widely available. And I just do want to, before folks jump off, if you haven't already, please go ahead and fill out that thank you poll while Emmett's answering the last few questions.
Perfect. Thank you, Jamie. And so how do you know if we need makeup air for running dryer, hood, bathroom fan all at once? Well, we need makeup combustion for a combustion appliance. It's a code required air. And then you might need relief air, depending on how big your kitchen fan is. One telltale is are our combustion appliances backdrafting when we're running those appliances? So sometimes you can feel that. Sometimes it can be dangerous, honestly, trying to do these tests. I've seen a couple examples where appliances failing and I'm doing a combustion safety test, and all of a sudden the CO in the house can get really high. We have to shut down and stop. So we have to be careful of that. And so maybe this is a good test for an expert who has a combustion analyzer and can monitor things. But if you're backdrafting your appliances, you need makeup air. And if you have a large kitchen fan, I definitely recommend a dampered relief air. It can be great. And then, do you have any resources for asbestos concerns? Removing popcorn ceilings. I've heard different things from contractors. I haven't dug into that. Arian, I'm sorry if I'm Arian Glover. I haven't dug into asbestos. I've worked around it. It's not safe to be around or breathe. And so you're probably going to need an expert for that if you run into. I'm sorry, I have to do some research to find any information on that to help you there. I don't have any now. Let's see if there's any others in here. Good question though about asbestos. We do have to be worried about that. Some of the old flooring tiles and some of the, I've ran into it in one house during an audit. And so there are piping systems with it in older parts of Fairbanks. I think that's all the questions. Is there one new message here? Great, good Good presentation. Thank you, James. Appreciate that. And I think I've got everybody's questions. Did I miss anybody? Feel free to jump on. It's always nice to talk to people.
I'll say it looks like you've answered everything so far.
Awesome. Okay. Well, I hope everybody enjoyed this. I really enjoyed presenting to you, everybody. And like I said, if you have more in-depth questions, if you don't, feel free to call me. If you have there's a lot of resources in the slides. And if you have a more technical question or a building issue, like I said, CoClimate's available as a resource as well. You're welcome, Brian. Nice. Thanks for being here. All right. I guess that's it, Jamie. Thank you.
Yeah, fantastic. Thank you, everyone. And like I said, you will be receiving an email with the slides and presentation in the next couple of days. Thanks so
All right.
much.
Thank you, everybody. Take
Bye,
care.
everyone.